Yeah, it's visible, ma'am. Ma'am, I have one thing to ask, ma'am.
Please go for it. Ask me.
Yeah, ma'am. Actually, the second class, the lesson two which you took of chemistry until now, the second class, the recording, it's sorry, like the class has happened for 58 minutes, but then the recording is only for 7 minutes.
Recording was there only for 7 minutes.
Yeah, ma'am. Something around 7.
How come?
I don't know, ma'am. I wasn't
Okay, I'll
able
do
to
one thing.
access more.
My number is available in a group already, right?
Yeah,
I'll
ma'am.
take a look if it is available with me. I'm a part of admin as well. If I could download, I'll download and I'll forward to you. Okay?
Okay, okay.
Or else,
Fine.
or else I have a PDF of the content that too I can share with you.
No, ma'am.
Okay?
Actually, if I get the recording, that's better, ma'am, because PDF I won't be
Yeah,
understanding
I'll
a
check
few
it. I'll check
important
it. If
things.
there could be any problem in the system itself, like we are follow some system, right? WhatsApp. So
Yeah, yeah.
if it would be a technical issue, I won't think like I could resolve it. I'll convey to sir and he try to resolve it. But then
Okay,
if it is not possible, then I'll forward you content or else one compensation period will be arranged for you. Okay?
fine.
Okay. So
Thank you, ma'am.
most welcome, no issue. Rest other students have joined or not? See how girls are sincere enough. Boys are not serious at all. They should be here actually to listen all those things and I'm speaking in front of you. Okay, no issues. This is what Mendel's periodic table. I hope you have downloaded the things.
Yes, ma'am.
Yeah. Even I have downloaded few things about it. Let me open it and I'll share with you. So whatever we have discussed yesterday, that we can continue in that. Okay, give me a while. Mendel's periodic table.
Ma'am, I have opened the Mendeleev's periodic table as well as the modern periodic table.
Okay, you have already, right?
Yeah,
Even I
yes.
have downloaded, but then I think okay, no issue. Other came or not yet? Okay, let it. They'll
No,
come
ma'am.
as per their wish. Let it be no issue.
Yeah, ma'am, one join.
Okay, fine. It's a horizontal way. Actually, I can't tilt it, but then let it be. I'll just explain you few things about the Mendeleev periodic table. So Mendeleev, what he did, he gave a name to the horizontal row and the vertical column, right? According to him, like these are the horizontal rows, and these horizontal rows he called them series.
Yes, ma'am.
Okay, and vertical column he called them groups.
Groups.
Okay, so this according to Mendeleev. And apart from that, he kept the blank spaces in his arrangement of the elements and whatever elements were known that time, he arranged according to increase in atomic weight. But then sometime he neglect the atomic weight and he try to put the element in same group with the same properties. And same thing he did for the tellurium and iodine. Though iodine has an atomic mass less than that of the tellurium, he kept iodine with what? Bromine, chlorine, and fluorine, right? And they are nothing but a halogen series. We know about it, right? Now. But in that time, it was completely new and invention, isn't it? Fine.
Yes, ma'am.
Now what we're going to see, we are going to see a modern periodic table, right? And what is the basic difference in between Mendeleev's periodic table and the modern periodic table, that we have to see thoroughly. Fine. Today's period, we are going to discuss about it. And even
Okay.
we are going to see the IIPS system to lab the different um, newly invented or newly discovered element. Invented and discovered, what is the difference in between invention and discovery? Are you aware about it?
Yes, ma'am.
Yeah, please let me know if you're aware.
Ma'am, invention is like when you uh, invent something that has never been existed before, and discovery is when you discover
It already exists,
something
but
which
we have
is,
found
yeah,
it
it,
now.
yeah,
It's a
exactly.
naturally found, right? But then
Yes, ma'am.
why I said inventory and even the discovery for these elements, because few elements are artificially made, isn't it? Because they were not existing to the nature, but because of the certain activities carried by the human beings, those elements came into existence, right? And hence I use both the word discovery and the invention. Understood?
Yes, ma'am.
Fine. Now, we are going to see the periodic table. There are the several form of the periodic tables, right? Yes.
Yes, ma'am.
But the modern periodic table, it follows we follow which scientist periodic table? Henry Moseley's periodic table is widely accepted. Who was this Henry Moseley and what he suggested to us? Because already we know that Mendeleev, right? What he said? Hmm? What he said? Atomic weight is a periodic function for the each and every element, isn't it? Yes or no?
Yes, right.
Then Henry Moseley, what he did, he plot two graph. Okay, he plot what? Two graph. In that, what he did, he took a X-ray of all the elements. See, X-ray spectra he took for the elements, and he plotted a velocity of X-ray, which is emitted by the elements with respect to the atomic number. And atomic number is denoted by Z. Okay. So what he plotted, velocity of X-ray emitted by the element with respect to atomic number Z. And he found a straight line graph for this. What he found? A straight line graph for this. But then same thing when he plotted
Ma'am.
with a atomic mass. Okay. And atomic mass is denoted with what? A.
Eh,
Correct? Yeah. That time he won't get straight line. It's not straight line. Okay. By that, what he come to know, atomic number is more and basic fundamental property of the element as compared to atomic mass. Okay. What he conclude, atomic number is more basic and fundamental property of element as compared to atomic mass. And hence, he modified the periodic law, which is framed by Mendeleev, isn't it? So what was the modification in his law? The law became now the physical and chemical properties of the element are periodic function of their atomic numbers. What was earlier here? Yes,
it was the
Shreyasi, what
atomic
was
mass
earlier
before.
here? Atomic mass. And that was which law? That was
Mendeleev's law.
Mendeleev's periodic law.
Yes.
Yes, and this is the modern periodic law. What is the modern periodic law? The physical and chemical properties of the element are periodic function of their atomic numbers. Clear? Fine.
Yes, ma'am.
Why? Why he considered it as a basic and a fundamental property? Because when he plotted the velocity of X-ray spectra emitted by the different elements with respect to its atomic number, he got a straight line graph, which is not found with the atomic masses. And hence he conclude that atomic number is more basic and the fundamental property of element as compared to atomic mass. Clear? Fine.
Ma'am?
Now, yes.
Ma'am, what do you like? Can you explain again the X-ray spectra one? I didn't get that.
Yes. What happened X-ray spectra? Have you in grade 9th you might have seen about the gold foil experiment,
Yes, yes, ma'am.
isn't it? So
Yes, ma'am.
whatever like rays emitted by the gold foil, right? And on scintillator mark has been made, isn't it? That is nothing but
Yes,
what?
ma'am.
X-ray spectra, and each and every element have their own like arrangement. Each and every element's atom has a different arrangement, different electrons, right? So according to that, it make a spectra. And with the spectra, when atomic number is been plotted, that time you get a straight line graph. Understand? How gold foil
Yes,
is reacted with the radioactive rays. In the same manner, different element give response to the X-ray. Okay, when the light is passed through it, it emitted in a different way, and that marks has been made onto the scintillator. Understand? And
yes,
when velocity is measured, so some detector instrument would be there in that experiment. Okay, it will detect the velocity of emitted ray, and that velocity is been plotted against the atomic number. Understood?
yes,
Clear?
ma'am.
Yeah.
Yes, ma'am.
Till there doubt or clear?
Cleared, ma'am.
And E plotted against Z. That time you get straight line. And when the same velocity you plotted against atomic mass, they won't be straight line. And hence Z is your more basic fundamental property as compared to A. Z is atomic number, A is atomic mass number. Clear?
Yes, ma'am.
Now see what is given to you here. The periodic law revealed important analogies among the 94 naturally occurring elements. Okay. So which are those elements? See, 94 are the naturally occurring. But then here, neptunium, plutonium, actinium, and the protactinium are also found in a pitch blende. Now, what is a pitch blende? Pitch blende means,
It's an ore of uranium.
yes, it's a ore, right? Pitch blende, it's a ore. And this ore is of uranium. Are you aware of the uranium? What is the symbol
Yes,
for
ma'am.
uranium? U. And atomic mass would be 232, isn't it? Kind of. Yes,
Okay.
because it
Yes,
has
ma'am.
many isotopes. So atomic masses would be vary for the uranium because it has several isotopes as well. Fine. Now, it is an ore
Yes,
of uranium. It stimulated renewed interest in inorganic chemistry and has carried into the present with creation of artificially produced short-lived elements. Right? Means whenever this pitch blende or uranium is being gone through the X-ray, or certain lights would be emitted, means like bombard or made to collide on it, it will emit a certain elements directly, and these elements would be what short lives. It has a short span of life. Okay, short span of life, only for few minutes, only for few seconds also would be exist. Understanding? Okay.
yes, ma'am.
Hence, this periodic law is very important, and it clear rest all analogies which cannot be cleared by any other classification table. Fine. Now, what is given over here? See, you may recall that the atomic number is equal to the nuclear charge. Okay, that is number of proton or number of electron. As we have learned in your grade 9, in an atom, okay, it consists
The
what? Three particles in it, inside it, right? Among those, two particles are in the nucleus and only one particle revolve around it. Correct? Two particles
yes,
which
ma'am.
are present into the nucleus, proton and neutron, right? And the particle which is revolve around it would be electron. Correct? Yeah.
Yes, ma'am.
And the charge on this would be what? Proton is positively charged.
Positive.
Yes. Right? Then electron is negatively charged and neutron is chargeless.
It's
Right?
neutral.
it's a neutral. Fine. So what is given? You may recall the atomic number is equal to nuclear charge. So nuclear charge can be positive, can be negative. And as we know that in an atom, number of proton is always equal to number of electron. And hence atom is remains neutral. Understand why atom is neutral though there is a positive and negative charge inside it? Because number of proton, charge on number of proton is equal to charge on number of electron, and the number of proton is equal to number of electron. So these two particles balance each other's charges. They compensate or cancel each other's charges, and hence total charge on an atom would be zero, or it is neutral. Got it?
Yes, ma'am.
Fine. Yeah. So what is given further? So it is then easy to visualize the significance of quantum number and the electronic configuration in the periodicity of elements. In fact, it is now recognized that the periodic law is essentially the consequences of the periodic variation in electronic configuration, which indeed determine the physical and chemical properties of element and their compound, and hence atomic number, which consists either number of proton or number of electron, and that is number of electrons are responsible for what? Electronic configuration, decide the physical and chemical properties of element, and hence atomic number is more basic fundamental property as compared to atomic mass of an element. Understand? Yes or no?
Yes, ma'am.
Yeah. Now see the further thing which is given to you. Fine. Numerous forms
Ma'am,
of
is this chapter entirely theoretical or numericals
no,
are
no, it's
also
not
there?
entirely theoretical. We have some few numericals also on the basis of this. Okay, you'll come to know.
Okay.
Currently, we have started with theory.
Okay, ma'am.
Some logical approach questions also would be there that we need to solve. Correct? And
Okay.
today I'm going to post few questions. You have to uh, join that test. You have to go for that test and you have to clear it today itself, either today or by tomorrow. By tomorrow by 6 p.m. it would end. Okay, I'll upload it today itself. Fine. So numerous forms of periodic table have been devised from time to time, but then currently we are using a modern version that is called as what? Long form of periodic table. Which version we are using?
Long form of periodic table.
Yes, long form of periodic table. Fine. So what is given in this long form of periodic table? There are again same thing, horizontal rows, right? And vertical columns. So horizontal rows are called as periods in a modern periodic table or long form of periodic table, and vertical column is called as a groups. How it's been called by the Mendeleev, the same name is given to the vertical columns. Okay, fine.
Yes, ma'am.
Now, elements having similar outer electronic configuration. Keep in mind, this is quite important. Elements having similar outer electronic configuration in their atoms are arranged in a vertical column. Okay, referred to as a group or families. And according to this recommendation, International Union of Pure and Applied Chemistry, a very first period when I took in my first lecture, just one might be aware, I gave you the long form of IUPAC.
Yes,
What
ma'am.
is
Even
this?
I saw the recording.
Yes. International Union of
Pure and applied
Pure
chemistry.
and Applied Chemistry. Now, what is the importance of this institute, or why this organization has been made? To decide a name of element, to decide the name of unit, and to decide the unit of that particular physical quantity. Okay, fine. Keep it in your mind
Yes, ma'am.
always. Fine. Now, why IUPAC system is involved in this chapter? By that, we come to know the name of element, newly discovered elements name can be kept by using this IUPAC system. Fine. So what they gave you according to the recommendations of International Union of Pure and Applied Chemistry, the group are numbered from 1 to 18. replacing the older notation from the first A to the seventh B and a 0. Earlier in the Mendeleev periodic table, if you would see, there would be the notation like first A, first B, right? Then the second A, second B kind of notation were there, right? And the last would be seventh A, seventh B, and the zero group element. And zero group element are nothing but what? Noble gases,
Noble gas. Yes.
right? Yes or no? What noble gases? Huh? Why
Neon,
we call them
argon.
noble gases? What are the noble?
Oh, okay. Noble gases are
Ah,
those
it
elements
will
whose
start with
outer shells are completely
it will
filled.
start with helium, I guess. Very good. Huh? It start with what? Helium, correct?
Yes.
Helium, neon, argon, krypton, xenon, correct?
Yes, ma'am.
Yeah. So these are zero group element. Okay. And now we are going to number it. This would be the last group, and the first group has a element hydrogen over here. So when you go from left to right, it will be your first group, and this last group would be 18th group, right? And earlier name would be first A, and this would be zero group. Okay. And the before that would be seventh B and seventh A. Correct? Seventh A and seventh B group over there earlier. Now these notation would be removed, and now we have named them from the first, second, third to 18. Okay, or 18th group elements are nothing but the noble gases. Correct? Yes or no? Fine. Now
Yes,
see
ma'am.
what is given to you further. Fine. After that, yeah, there are altogether how many groups and how many periods are given that we have to see. The next para is explain that only. And apart from that, we are going to see the nomenclature of newly found element to avoid any confusion among the scientists. Okay. See what is given to you in this. There are altogether 7 periods and how many groups? 18 groups. Just now we have seen, right? Each and every period consists several number of elements. The number of elements would be vary, okay? Because these all elements are kept according to their properties and atomic numbers. Fine. So there would be how many? 7 periods. 1, 2, 3, 4, 5, 6, and 7 period. Among that, first period has 2 elements. Okay. Second and third, these 2 periods has 8 elements together, means 8 element each. Sorry. Okay. Then fourth and fifth would have how many? 18 elements altogether.
18.
Means not altogether, I'm sorry. Each. 18 element each.
The last two will have 32.
Yeah. And last, sixth and seventh would have 32, correct?
32. Yes,
Quite
ma'am.
differentiation is given about these two. See what is given about. See, 2, 8, 18, 18, and 32. 2, 8, 8, 8, 18, and 32 means about they have given the 32 elements. And seventh is incomplete period. Okay. And the sixth period is the period which consists a largest number of element inside it. Okay. Apart from that, in a sixth and seventh, few elements from the sixth and seventh group is been kept around 14 elements is kept at the bottom of periodic table. Okay. As they are started with the lanthanum and the actinium. Okay. These two series are called as lanthanide series and actinide series. Okay. Understood?
Yes, ma'am.
The elements which supposed to be kept into the sixth and seventh group, right? But because of the small space and the similar properties, we cannot club them into the only one block, right? And to study them separately, individually, we kept in a long form of periodic table at the bottom of periodic table, and these series are called as lanthanide series and actinide series. Okay,
So,
fine.
ma'am, instead of these
Yes or no?
series, ma'am, the name over there is given as lactinite and actinide as the element. Oh, okay.
Yes. Because this series has been started with lanthanum, and this series will be started with actinium. Right?
Okay.
These are the two
Yes.
elements present in the periodic table. And after lanthanum, 14 elements would be there which have a similar properties. After actinium, 14 elements would be there which have a similar properties. So we cannot keep them in only one block. Can we do that? All 14 element in one block? We can't, right? And to study them individually and to understand their properties, we kept them at the bottom of periodic table, right? And in a periodic table, we gave them a block called as lactanide series and actinide series. And after that, we not enrolled those 14 elements immediately over there. We are kept at the bottom of periodic table and gave them a separate name as a lanthanide series and actinide series. Okay, you'll come to know. I'll show you that. Give me a while.
So,
Periodic
ma'am,
table.
in lactinide series, all of the 14 elements they have very similar properties.
Sorry.
All of the lactinide series, the elements present in that, they have very similar physical properties.
Yes. Their configuration would be different. Means like outermost, like rest all properties would be same. That is also we have to learn as a separate chapter.
Okay.
Yeah,
Yes,
we
ma'am.
have to learn as a separate chapter in your grade 11th and 12th. I'll let you know how. Just give me a while. Let me share the screen with you. I hope you are able to see this. Fine. Is it visible now?
Yes, ma'am, it is.
Fine. You can check over here, beta. Now see, the first period is this. It consists how many? Only two elements, right? Annotation. Where is annotation? These two
Ma'am,
elements are,
there are two more things above the lactinide actinide series, right, ma'am?
sorry, what? See, here they have
Aren't
given
there
you.
like supposed
You
to
able
be?
to this say you are able to see or not? Lactinide to
Yeah.
Sebium, right? And actinide to nobelium. So here how many? 14 elements are there altogether. See, lanthanide, LACEPRMB. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So these 14 elements should be placed in this green block. Able to see?
Yes, ma'am.
Yes. And the similarly actinide, if you see, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So these all 14 elements should be in between actinide to nobelium at this place. Understood? So all 14 elements we cannot fix into this one block, right? Which have a similar properties. And hence they are separately placed at the bottom of periodic table. Lanthanide series and actinide series under the name. Got it?
Yes,
Fine.
ma'am.
Yeah. Now you can see further in the first one, hydrogen and helium. There are only two elements. In second and third group, we can say 1, 2, 3, 4, 5, 6, 7, 8 elements. Again, 1, 2, 3, 4, 5, 6, 7, 8 elements. Now in fourth period and fifth period, you can check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And the similar for the next one, fifth, isn't it? Now, sixth
Yes, ma'am.
element have a largest number of, sorry, sixth period has a largest number of element inside it. That would be see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. These 18 and these 14. 18 and 14, how many? 32.
40 to
Correct?
32. Yes.
Yes. And seventh period is incomplete period because newly found elements has been enrolled in that, isn't it? Yes or no?
Yes,
That
ma'am.
about some form of periodic table. Even you can check these two groups. First two groups are given here with helium are called as S block elements, right? Yes or no?
Yes, ma'am.
See, yes, block elements, right? Then the transition metals, right? From the here 21 number, are you able to see? 21 to the 112. These are what? This blue color, right? Yes or no? It is what?
Yes, ma'am.
It is what? D block
Transition metals.
transition metals, and transition metals are D block elements, right? How you're going to keep in your mind
Yes.
scandium, titanium, vanadium, chromium, manganese, ferrous, cobalt, nickel, copper, and zinc. So I give you a one Sanskrit shloka, means like kind of things. By that you can keep it in your mind, like skati vakramana feko nikuns. Huh? Right? Ka,
Yes, ma'am.
scandium, T, titanium, vakra, vanadium, chromium, mana, manganese, fe, feco, feco मतलब Fe, ferrous, Co means cobalt, nickel, okay, Cu means copper, and zinc, correct? So you will understand the transition metals series. And below that, whatever elements would be given, that would be a P block elements, correct? Skativa, Kramana, Feco, Nikuns. Fine. Apart
Ma'am,
from
if we like know the periodic table like up till 30 elements, we easily know the transition metals, right?
yes, yes, up to 30 elements. Scandium to,
Okay, fine.
okay. And whatever would be below that series, definitely it would be P block elements, sorry, D block elements only, not P block elements. I'm sorry. That would be D block elements. It's a transition metals. Fine. Now,
Yes.
if you come here towards the non-metal side, right? Boron onwards. But then from boron, one zigzag line is also goes. Boron, silicon,
They are called
arsenic,
metalloids.
tellurium, yeah, AT and OG. These are what? These are what? These zigzag lines suggested. These are what? Semi-metals. You can say it is semi-metals or
Or
metal.
metalloids.
Yeah, means these are shows the properties of both metal and non-metal, right? And these elements are what? P block. These elements are P block elements. Fine. Okay. And the last 18th group elements are nothing but noble gases. Already I explained you about it. Isn't it?
Yes,
Yeah.
ma'am.
Yeah. Helium, neon, argon, krypton, xenon, radon, etc. This is newly found. I need to check the name of this 118th elements. Okay. And see the lanthanum and actinium, it start with lanthanum and it start with actinium. And because of that, it is called as lanthanides and actinides. And that series are below the periodic table. In detail, we have to study. It will start with the atomic number 57 and with the atomic number 70. And it will start with the atomic number 89 and end with the atomic number 102. Got it?
Yes, ma'am.
Understood clearly? Fine. No issue. Okay.
117
Before
and
coming there, let's
118 are
understand.
new, right, ma'am?
Sorry.
117th and 118th are new, right, ma'am?
Yeah, 118th is new one, newly found.
Okay, okay.
Yeah, fine.
Its name is Organoson.
Yeah. He went or what? Just one. He
Yeah,
was there.
yeah, he went, ma'am.
Might be some network issue would be there, I guess.
Hmm.
Fine, no issues. Now, again, we are going to jump here on our previous page. So quite interesting part is given to you now that you need to focus, because mostly a kind of logical questions asked on it. Fine, normalization of elements, right?
Yes, ma'am.
So the naming of new element had been traditionally and the privileged of the discovery. So discoverer and the suggest the name was ratified by the IUPAC, correct? That is International Union of Pure and Applied Chemistry. In recent years, this has led some controversy because the new element with the high atomic numbers are so unstable, and that only for the minute quantities or sometimes only few atoms we can means like catch of those particular element. And for that also well equipped laboratories are required, and that are so expensive laboratories, right? And because of that what we need to be very conscious while discovery of the element. What they have given here, see, such work is carried out with a competitive spirit only in some laboratories in the world. Scientists, before collecting the reliable data on new element at time, get tempted to claim for its discovery. For example, both American and the Soviet scientists claim to credit for the discovery of element of 104 atomic number, right? And the name of that Americans given to that particular element, that is nothing but rutherfordium, okay? And Soviet person gave name to that, that would be Kurchatovium, right?
Yes, ma'am.
The
Even like
confusion.
Einsteinium and all that also there, right, ma'am?
Yes, yes. So atomic number is what? Same. That is 104. But the name suggested by the Americans would be different and the Soviet person is also different. And hence, IUPAC made a recommendation that until new element discovery is been proved and will not be approved by the IUPAC system, till that time, a temporary name should be kept to that particular element. And how you're going to keep that temporary name? By using these abbreviations. For the digit 0, you have to use nil and the abbreviation will be N. For the 1, it would be un, abbreviation would be U. For 2, it would be bi, abbreviation would be B. For 3, it would be tri, abbreviation T. So this chart you need to follow. Fine. Yes or no? And by using
Yes.
this, how you're gonna label it, that we are going to see. You can check 101. It's given to you, right? How are you going to keep the name for 101? By using this chart 101. Hmm? Nium you have to add, NIUM you have to add after these abbreviations.
You start with
Correct?
UN and then it ends with
This
IUM.
no, you have to check it. You have to check the number one. For number one, what it would be un, correct?
Yes.
I'm going to write un. Fine. Then number zero, what I'm going to write for the number zero? Nil.
Nil.
Correct? Ah. Now for again one, it would be again un nil un. Okay. And after that, you have to write em. Here you can check the name. I have to move it.
So it's 101. If it's 102, then it will be
Ah, yes, yes,
Unibium.
yes. Unium. Unium. NIUM actually it should be. Okay. I think
Okay.
I have written double. Twice I have written, right? It should be only once. I'll show you how. Anil and Nium. It should be UM. Fine.
Yes, ma'am.
Got it? Fine. For 102, what it will be? Nil,
Anilbium.
huh, binium. Hmm? You can check this. Bium. Fine. And abbreviation for the
Yes.
first one would be U, N, U, N, U. Second would be U, N, B. Correct? In this way. For the third, un, nil, trium. Okay, U, N, T. right? And later officially name is given by the IUPAC system. And that IUPAC name or IUPAC system name would be given on the basis of what? Either
The
to honor
discoverer's
that
name.
particular scientist by the name of scientist, okay, or else by the name of country, right? Or by the name of state of country where it found. By
So
the name
wherever
of
it
state
is
of.
found, that same country's name is added with IUM.
It depends. It depends. It depends completely on the members of IUPAC system whether they approve it or not.
Okay.
Sometimes they will give a name of scientist. Sometimes they will give a name of country. Sometimes they will give the name of that particular state of country where it found. Got it?
Yes, ma'am.
Yes or no? Fine. So one question is given to you, and even the answer is there in your PDF. That once you go through, fine. And few questions related to this I'm going to post. You have to solve. Check this problem 3.1. What would be the IUPAC name and a symbol for element with the atomic number 120? Hmm?
Unbenyllium.
And by nil
EM.
em, है ना?
Yes,
Correct?
ma'am.
Check the answer 120 and by nil. Hence the symbol of name respectively unbinilium. Okay,
Yes, ma'am.
fine. So now I think we have to stop. You have to join for your next class. Tomorrow, same time, we will meet again. And tomorrow we are going to look some problems on or questions on the basis of this. Already I'm going to post some questions that you have to solve. And once you have done those questions, we are going to discuss in tomorrow's video. Fine.
Okay, ma'am.
And if you have any question from your side, your end, please let me know. Fine.
Okay, ma'am. Yes, ma'am.
Fine. Take care till the time. Bye.
Thank you, ma'am. Bye, ma'am.